So today we're going to learn about neutralization and titration. These are both words that have to do with acids and bases. So we're going to do neutralization first, and right in the word you see the word neutral, right? So right here we are literally creating a neutral solution, and the way that you do that is by combining an acid and a base. And what happens is that base and acid combine and they make water and salt. That's the neutral solution. So what this is going to look like in a reaction is you'll always have an acid and a base as the reactants, and you'll always make water and salt as products. So remember, acid will always have an H at the beginning, so it'll be H plus something. A base will always be something and it will have an OH at the end. Water, obviously we know is H2O, but another way to write water, it could also be written as HOH, still two H's and an O. And then lastly, the salt is basically any sort of ionic compound that will be left over. So we're going to look at several examples of this. So you've got these on your paper. So we're going to try to identify and name some of these things. So first I want to find in the reaction where's the acid and where's the base. So here, because I see this H in the beginning, there is the acid. And the other reactant has OH at the end, so it is the base. Okay? Notice the products. Here's HOH, here's the water that we made. Now, this over here, the NaCl, this is the salt. That's the ionic compound that was formed. So what we're going to try to do is we're going to try to name all of these pieces. So remember acids, they have to end in ic acid. Because this is H with a single element, the name will start with hydro. Then because it's chlorine, we will say that it is hydrochloric acid. NaOH, anytime you have a base, it's just regular ionic naming. There are no prefixes, nothing like that, so we're just going to call this sodium. Sodium does not need a Roman numeral, it only has one charge, and it is sodium hydroxide. The hydroxide piece is the name of the OH part. Water we can leave named as water. Lastly, we're going to try to name the salt. Again, salts are ionic, so we're going to follow regular ionic naming rules. No prefixes, nothing like that. The Na is sodium, and the Cl is chlorine, and we will change the ending to chloride. So that's neutralization. You always have to have all four pieces from the general reaction. So let's try another one. In this one, if I look for the acid, it's over here, and it doesn't matter that it's not first, it's still on the reactant side, so that's fine. I know that it's the acid because it starts with an H. I see this OH at the end here, this is the base. And over on the other side, the water is written here, the HOH or H2O, which means that this other piece must be the salt. So, see if you can name all of those pieces. The base is called aluminum hydroxide. Again, ionic naming, no prefixes or anything needed. For acids, whenever it's an acid with a single element, you have to use the prefix of hydro, and this is hydrosulfuric acid. The water name I'll leave alone. We'll name this other salt over here. It is aluminum, which does not need a Roman numeral, and it is sulfide. Ooh, that was strange. Notice that that's different than sulfate. If it was sulfate, then you would see SO4 in the name, or in the formula. Okay, but a single S, just something from the periodic table, it's still okay to have that "ide" ending. Alright, now we're going to make it a little harder. Now you only got a part of the reaction and you have to figure out the rest. So we're still going to look at the parts just like we did before. H at the beginning, here's the acid piece. OH at the end, here's the base. So we know that one of the things we have to make is water, which is HOH. Doesn't matter if you write HOH or H2O, same thing. But I want you to look at where the pieces came from. The H from the acid became that part of water, and the OH from the base became that part. So that's what the acid and base are doing. They're combining to make that water. That means that we are going to use the leftover pieces. We haven't done anything with the F or the K. That's where your salt will come from, is those leftover pieces from the acid and the base. So we always have to write the positive thing first. K has a positive 1 charge, that's based on its group in the periodic table. F is a -1, again based on its group. Ionic things we crisscross to make their formulas. So, when I crisscross this, the formula of that piece is KF. That is the salt that gets made in that neutralization reaction. So now that we have the whole thing, we can name it. So HF, again, it's H with a single element. Oh, let's make that red. Gotta have everything match. So hydro, because it's with one element. Fluoric acid. Let's make that a C. The base, you do regular naming, no prefixes, so I just say potassium. That does not need to have a Roman numeral, it only has 1 charge. And OH is called hydroxide. If you want to name water fancy, you could say dihydrogen monoxide, but it's fine to just leave it water. And now let's name this new salt that we made. Again, it's ionic, so we're not going to use prefixes. So this is called potassium. And the F is fluorine, so we rename it as fluoride. So now let's see if you can take these last 2 reactions and can you name them, and then in this last one can you write the final products and name what they should be. So try it for yourself. Okay, so what we have here is the acid because it starts with an H. This is a base because it ends with an OH. The products always have to be water somewhere, which means that the last piece is the salt. And now let's try to name all of them. For the acid, this time it's H with a polyatomic ion, so you will not use the hydro prefix. You'll just notice that this is phosphate, so we will call that phosphoric acid. We did not use hydro because it's with a polyatomic ion instead of a single element. The base we can call just normally, that is barium, which does not need a Roman numeral. And then for the OH piece we say, let's get the right color here, hydroxide. For the pieces that were made, we know we have water. Our salt is called barium. Again, it's ionic. We're not going to put prefixes. And the name of the PO4 is phosphate. Remember, when you have a polyatomic ion and you're naming it, you don't want to change its ending. Now for this one, let's take a look. Our acid is here because it starts with an H. Our base is here because it has an OH at the end. So we know we have to make water, which is HOH. So the base donated the OH part, and the acid donated the H part. That means the leftovers, this NH4 and this HCl, are what's going to form my salt. So you have to know their charges. Remember, no hugs for Juan. So I know that that's the positive piece that will get written first. Cl, if you look at its charge on the periodic table, is a -1. Then we're going to crisscross applesauce. The formula for that salt is NH4Cl. Okay, so we still have the same products. You have to have water and you have to have some sort of ionic salt. Okay. Lastly, we're going to try to name these pieces. So we're going to have an acid, and it's with a single element, so we're going to call it hydro, and it's chlorine, so chloric acid. Our base, NH4, is called ammonium, and OH is called hydroxide. Okay. We know we have water, and let's name the new salt that we made. So that is NH4, again that's called ammonium. And Cl is chlorine, so we change that ending to chloride. So all of these are examples of neutralization reactions, and now we're going to talk about what they're used for. Okay, so we do neutralization reactions a lot. In the lab we do them for things called titration. A titration means you're going to determine the concentration of an acid or a base, and the way that you do that is by neutralizing it and see how much does it take to make this neutralized. Remember that we've talked about concentration before, and that means the same thing as molarity, which is our big M. So this is going to go back to the molarity formulas that we know. Okay? This is a picture of the setup of how you would do this actual experiment. And so you would have what's called a burette. That's this long tube right there. And you could put some base in there. And in the bottom, I could put a little bit of acid. And as I slowly let this base drip down, it would neutralize the acid. And the way that we can tell when things are happening is with the acid, you would also put an indicator. Remember, indicators are things that change color. And so once it changed color, so I know it's not an acid anymore, I would know that the neutralization reaction is completed. And I could see how much base did it take for that to happen. And then, of course, there's math to go with that. So this uses our MV formula, except now we're going to have acids and bases in it, but the math is still going to be the same. Okay? So grab your highlighter, find some numbers. And so in this question it says, what is the molarity? That means I'm missing one of my M values. So we're going to write M1V1 equals M2V2 equals. Okay? So maybe I don't know M2. Right? So that's the basic solution. It tells me I start with 30 milliliters, and that's the amount of basic solution. So that goes over here. The initial molarity of the acid that I started with was 2.50, and the amount of that I had, whoops, I don't know what that was, let's see, 26.4 milliliters. That's my volume. And now you're just going to solve this with regular algebra. You're going to combine like terms. So I'm going to multiply right here. 6.6 equals 30x. Divide by that 30. X equals. Calculator says 0.22, and of course you're going to check sig figs. So I started with, oh, see, this is wrong. I started with 3 sig figs everywhere. As written, this only has 2. The way that we're going to fix that is it's okay to add another 0 at the end. And then because we were looking for molarity, the unit for that is a big M. So that's how much the concentration of the basic solution that this would need. Okay? See if you can do number 2. Alright, let's check it out. So numbers that I see here, here, here. This one says, what is the concentration? Remember, concentration means the same thing as molarity, so we'll be looking for one of the M values. Okay, so maybe X is there, I don't know the M. Doesn't matter which side you put it on, either way is okay. So it tells me for the acid that we have 49.90 milliliters. That's a volume number because it's milliliters. And the concentration of that solution is what's right next door. So 0.59. I don't know M2, the other volume that I have, the other milliliters number is this 25.00. Okay? Now we're just going to solve with regular old algebra. Combine your like terms. So on this side I get 29.441 equals 25x. Divide by 25. X equals. So my calculator says 1.17764, and we're going to check out our sig figs. So there's 4 here, but only 2 here. When you have the option, go low. The second sig fig is here. The 7 though means I have to round that up, so my answer is going to become 1.2. And because we were looking for a concentration, that's an M value, so you have to put an M on there. Alright, that's it. Let me know if you have any questions.